So the ball starts off on a cliff, and it rolls horizontally, so it's going to the right, and eventually it's going to fall down. So this is the type of trajectory that we have in this problem. Next, make a list of what you have. We have the speed of the ball as it leaves the cliff. Since it's traveling horizontally, we have the speed Vx. So Vx is equal to 20 meters per second. Now it takes 10 seconds for it to hit the ground, so we have the time. Calculate the height of the cliff, that's h, and the horizontal distance traveled by the ball, which is the range. To find the height of the cliff, we could simply use this equation. H is equal to 1/2 at squared. Now a, we can use 9.8. If you use negative 9.8, h is negative, but what it really means is that the vertical displacement is negative because the ball is going down. But for all practical purposes, we want the height to be positive, so let's plug in positive 9.8. And t is 10. Half of 9.8 is 4.9. 10 squared is 100. So 4.9 times 100 is 490. So that's the height of the cliff, since it takes 10 seconds to hit the ground. Now let's calculate the range. The range is equal to Vx t. And we know Vx is v cosine theta, but we already have Vx, which is 20. So therefore the range is going to be 20 meters per second multiplied by 10 seconds. And you can see that the unit seconds will cancel. 20 times 10 is 200. So the range is 200 meters. And that's it for this problem. A ball rolls off a cliff that is 200 meters high. Calculate the time it takes for the ball to hit the ground. So for this problem, we have a similar trajectory. It rolls off the cliff, and then it hits the ground. And our goal is to find the height. And we know that the height is 1/2 at squared. Actually, we have the height. Our goal is to find the time it takes to hit the ground. The height is 200. The acceleration is 9.8. And let's solve for t. So half of 9.8 is 4.9. To isolate t squared, we need to divide both sides by 4.9. 200 divided by 4.9 is about 40.8163, and that's equal to t squared. So now we need to take the square root of both sides to get t. And so t is going to be 6.389 seconds. And so that's how long it's going to take for the ball to hit the ground. A ball is released from rest and drops straight down, starting at a height of 800 meters. How long will it take to hit the ground? Now, what if the ball was thrown straight down with an initial speed of 30 meters per second? How long will it take to hit the ground now? So let's draw a picture. So let's say this is the ground level. And here we have a ball. And we're throwing it down. Well, for the first one, it's going to be released from rest. And it's going to fall straight down. What is the initial speed if it's released from rest? Now, there's no Vx component because it's not moving to the left or to the right. It's falling straight down. So initially, Vy is equal to 0. If it drops down and being released from rest. Now, in the other example, Vy is not 0. The ball was thrown straight down. So Vy is negative 30. The speed is positive, but the velocity is negative because it's going in the negative y direction. In each case, the height is 800 meters. So what can we do to find the time it takes for it to hit the ground? In the first example, you can simply use the equation h is equal to 1/2 at squared. h is 800, the acceleration is 9.8, and we can solve for t. Half of 9.8 is 4.9. 800 divided by 4.9. That's 163.265. And that's equal to t squared. So now we can take the square root of both sides to get t. So t is 12.78 seconds. Now what about part B? How can we find the time it takes for it to hit the ground if there's an initial speed? So recall that this equation comes from this expression. dy is equal to vy initial multiplied by t plus 1/2 ay times t squared. Now we need to be careful with the way we are going to use this equation. We're going to put the negative signs in the problem. So we have to be careful. Using this equation, we didn't have to worry about the negative signs. Now the ball is traveling 800 meters in a negative y direction. So the vertical displacement is negative 800. We do have an initial velocity in the y direction. It's negative 30. So we need to take that into account. And then we have plus 1/2. Ay, the acceleration in the y direction, is negative 9.8. So this is going to be negative 4.9 t squared. Now let's move everything from the right side to the left side. So this is going to be positive 4.9 t squared on the left side, plus 30t, and the 800 is going to stay on the left side, so it's still negative 800. As you can see, we have a quadratic equation in standard form. To solve for t, we need to use the quadratic formula. So let's make some space first. So here's the quadratic formula. T is equal to negative b plus or minus square root b squared minus 4ac divided by 2a. So a is 4.9, b is 30, c is negative 800. So this is going to be negative 30 plus or minus square root. 30 squared is 900, and then this is going to be minus 4 times a, which is 4.9, times t squared, times c, which is negative 800, divided by 2a, or 2 times 4.9, which is 9.8. So now let's multiply these three numbers. Negative 4 times 4.9 times negative 800, that's equal to a positive 15,680. And we still have a 900 next to it. So now let's add those two numbers. If we add 900, it's going to be 16,580. And the square root of that number is 128.76. Now, there could be two answers. Negative 30 minus 128.76 and plus 128.76. We know time can't be negative, so we're just going to ignore the negative answer. So, if we take negative 30 plus 128.76, that's positive 98.76, and divided by 9.8, this will give us a t value of 10.08 seconds, which is less than the other answer, which was 12.78. Because in the second example, the ball was thrown towards the ground, it's going to take a shorter time to get to the ground, since it was given that initial speed. And so it makes sense why it would be less. Now we can check the answer. If you plug it into the original equation, we need to make sure that we get 0. 4.9 times 10.08 squared plus 30 times 10.08, that's 800.27 minus 800, that's approximately 0. So this answer is correct.